All right, so all right, I guess it's full screen now. So hello everyone. Welcome to our machine learning workshop. Very excited to be doing this. My name is Lulu, and in today's workshop, we will be introducing you to machine learning, and then also introducing you to natural language processing. And with those, we will also be doing a hands-on project, and we'll build out a Twitter sentiment analysis model, a actual machine learning model to classify tweets, and it will be hands-on, so you get to code, and you can follow along, or you can just watch the video. Right, so let's get started. So yeah, I am an ML engineer at Unity Technologies. I've been working there for 6 months now, and I'm also a co-founder of Project Alicia, which is a project on doing data analysis, on data engineering, and also ML engineering. And so yeah, you can check it out. It's a very cool initiative on ML and data privacy. And I also just graduated from McGill. My research and thesis was on applied machine learning, and it was in big data analysis in the urban and transportation domain. So it was really fun, and I learned my research was quite intense, and I was able to finish my thesis and had some really nice conferences where I met a lot of ML researchers, and also had some publications in that area also. So you can also find me on LinkedIn, so lulu10.lt, and can also check out some of our page that we just launched on Project Alicia. All right, so let us get started. So what will we do today is we will be taking a shallow dive and also a deep dive into machine learning. Then we'll be also introducing you to natural language processing. If you don't know what that is, we'll know very, very soon. And then we'll also be learning a lot about Python. So if Python is something that you're not very familiar with now, hopefully by doing this workshop, you'll get a little bit more familiar with it, as it's actually a very important language for machine learning. A lot of people, most people, it's the primary language for ML, I would say. And yeah, we'll wrap it up with a fun project in where we will try to classify between a positive sentiment tweet versus a negative tweet. So whether a tweet invoke positive emotions or if it's a negative tweet. Some of the things you will learn is from this workshop, I hope to introduce the entire ML workflow. So starting from the problem statement formulation into doing data preprocessing. So cleaning the data, wrangling with the data, then doing feature engineering, and then actually building out the ML models, and also how to evaluate the models that you build, which is also very important. So how to evaluate some metrics for accuracy, how to know which model is the best, which one to pick, and also some weakness in your ML model. So these things are essentially the ML workflow. And you will also get to see lots of libraries, pandas, scikit-learn, NLTK, NumPy, matplotlib, Seaborn. These libraries are very popular in the ML domain. As you go further and learn more about ML, it's a very nice thing to learn and have in your toolkit, I would say. All right, so let us get started. So now, start with what is AI, and then what is ML, and what is natural language processing, and also what is deep learning. So AI is an umbrella term for any human-like intelligence exhibited by computer, robots, and machines. So machines can essentially simulate the human intelligence and our ways of thinking, and it ranges to anything from a recommendation systems, any predictive modelings, and also self-driving cars. So it's a big umbrella term. Everything else lives inside AI. Then we will look into ML, machine learning, and then NLP, which is a subset of AI. So let's start with ML. So ML is essentially just computer trying to learn. It's trying themselves to self-learn and improve over time without being explicitly programmed to do so. So without us stating, if this happens, then we execute this action. It's self-learning and improving, finding patterns in data and making its own predictions. Then NLP is another subset of AI, and it's also actually it's also crossing with the ML domain also. But natural language processing, it deals with how computer understands and translate human language, because the language we use every day is actually very complex, and we need some special, for example, data processing and feature um, translation and engineering to allow the computer to learn language over through that. So some applications would be like the Google Translate you use, and also the sentiment analysis model that we'll be building, as long as some AI bots. Those are some things that's crossing with NLP and also with ML. And then, but then to really automate and deliver the response from NLP, we need ML. So this is where ML comes in, is to automate our responses. And we'll not go into detail, but deep learning is also a very important field and a very hot field too. A lot of research are going into neural networks. So neural networks are essentially multi-layered networks that you can think of it as the brain. So neurons and networks and layers in which it can process large amount and also very complex information. So today we'll be sticking with ML and also NLP. All right, so how does ML work? Well, this is a very important workflow that we will be keeping in mind for the rest of the workshop. So once you have defined your problem statement, your ML problem, which is for us is to build a sentiment analysis model, we'll first need to wrangle with the data. We need to process the data. Then we develop the model, and then we train the model. And lastly, we test and analyze our model's result. And if we're satisfied with it, so if our model is of very high accuracy and we are good with it, then we can go live, so go into production. Or else we can do a retraining, adjust some hyperparameters, and do a complete retraining of the model. And you'll see what I mean in just a second. So, and then also now I'll be going into talking about the supervised learning. So supervised learning is a branch of machine learning. Machine learning has supervised learning, unsupervised learning, and also reinforcement learning. So supervised learning in this case is that the algorithms are designed to classify things, find patterns, and then predict outcome. And in this case, it will always have an input and always have a target. So you will always learn from the target or the output label to know what your input data is. So this is like in unsupervised learning, you would not have the output, for example. So you feed the input data, for example, it's an apple, and then the model through time will learn if it's an apple from checking continuously over and over again, like doing iterations and epochs to see whether the prediction is apple. And then you'll be able to, at the end, classify between apples and bananas. So the takeaway from supervised learning is there will always be an input and there will always be an output for your target, for the model to learn. All right. Then now we come into the domain of NLP, which is understanding language, and where the majority of our time will be spent in this workshop. So language is very complex in a way. So even this very simple sentence, such as literally your Facebook message app is useless. You only wanted to increase profit. Please fix yourself. It's sad at Facebook. So even this very simple sentence contains a lot of information. For example, we can see like the emotions. It's frustrated because it contains words like useless and sad. And then we can also see the organization. So the organization is targeted for Facebook. And then the product is the message app. And we know it's the English language and it's informal. So language is very interesting in this case, that even this little tweet has a lot of information that we can learn, we can play with. So what can we do with NLP? Well, we can do sentiment analysis, we can build AI chatbots, we can do translation. The Google translation, I think it's powered by neural networks. And then we can also do text classification as well as speech recognition. So it's very applicable and very useful. Okay, so now those are the very like a crash course style on ML and NLP. So that's very quick. So of course, there's so much more complexity behind it, but I think it's enough to actually get us started on the project. So the project is, we can see some of these tweets I put here. So this one says, even the darkest night will end and the sun will rise. Just us humans reading it, we can feel that it's a positive tweet, as it's give us a positive sentiment, like it's invoke positive emotions in us. And then on this one, it says nothing is worse than watching someone you want someone else. Well, that one invokes some mixed feelings and also slightly more negative tone than this one. And then the last one is also very interesting because it says, take more pictures, always say, I love you, never go to bed mad, jump first, think second, love harder, love deeper, life is too short. So if we take everything before the last sentence, it's very positive. But the last sentence, life is too short, that has some a negative feeling towards it. But overall, if as humans, we can just see, okay, so this is a pretty positive tweet. It really encourages me. But maybe machines, they would see the last sentence and say, okay, what does this mean? Is the overarching tweet a positive versus negative? So we'll need to build a model that's smart enough to recognize whether or not a tweet is essentially positive feeling, positive sentiment, or negative sentiment. So yeah, our really going into the project is the Twitter sentiment analysis. We'll start with exploring the tweet, the analysis, doing an analysis on it. So checking out what the tweet distribution, its length, its hashtag. So also lots of data cleaning, because not all tweets are clean. Like we have to remove punctuations, special characters, and then feature engineering is also very important. I'll talk about that in our later stages, but we'll use a technique called bag of words. Then we'll be building out two ML model. The first one is a decision tree, and then the second one is a random forest. And lastly, we will see which of these two models we build has the best accuracy. And I'll also be introducing the one of the metrics that's very important is called confusion matrix to evaluate our accuracy. So this is basically it for the intro part. And I guess I can start with the project if everyone is ready to do so. All right. Oh, sorry. So I believe the link has been sent out to the chat on the Google Drive, right, Lila? Or
I'll add it again right now.
Okay.
I'll add both links.
So yeah, both links would be, I'll be using a Anaconda IDE and then also the Google Drive. Okay.
If you didn't have time to download Anaconda, you can try to do so now, or you can use PyCharm.
Yep. You can use any IDE you want, like Sublime Text, Visual Studio Code, or yeah, Spider, anything. So this is the folder you would have. It contains our training data set and then a template and also a requirement.txt. Okay, so I'll get started with the project then. So just open up your terminal in where I already opened up, and then I put my folder in on the desktop. So you guys can put it anywhere you want, but the first thing I'm going to be doing is just cd into it. So cd into my machine learning workshop Twitter sentiment analysis with the date. And then you should be able to see all of these: template, test tweets, train.csv, and then also requirements.txt. Okay, so if you're on Anaconda, the first thing I'm going to be doing is actually creating a new virtual environment for it. And on Anaconda, it goes like conda create name, and then this environment, I want to call it the maybe Twitter proj. I'm going to just a virtual environment where I'll be putting all my requirements, where I'll be installing all my requirements in. And if you're not on Anaconda, you can just like py-mv-env-inf in your command prompt or on your terminal. And then I created it, and then now I have to activate this environment. So it's just conda activate Twitter proj. All right, so we can even see it for here, Twitter proj. That means I'm on my virtual environment. I'm no longer on base. And then the first thing I'm going to do is to install all the requirements that I put into, which is in this txt file. It contains pandas, matplotlib, seaborn-nl, tk, scikit-learn, and word-cloud. You can install them one by one, but yeah, but you can also install C, conda, forge, and the file name is the requirement.txt. This step would take a lot of time, take a bit time depending on how fast your internet is and how fast it downloads. So yeah, we're just gonna be just waiting it out till everything is downloaded.
I actually said in the comment section, if anyone has questions, we'll save them for later. So can we answer one now?
Yeah. Answer them now. This one will take some time.
One question is, what if the tweet is a mix of 2 or more languages and every language displays different emotions?
Oh, that's a very good question. So that means we would have to do, in the pre-processing, we would have to separate those languages. Like we cannot mix, for example, Chinese, English and French together and process them. So you would need to separate those language and then build them. So we will be seeing how we can use the NLTK language model to really get to select those language you want to do. But that's a really good question. Those we can deal with those in the data cleaning stage.
Someone mentioned if we could repeat the command line steps quickly.
So you would want to first cd into your folder, and then you would want to be doing, let me find it. Oh, like after you have made all those virtual environment, you want to do, yeah, I couldn't find it, so you will want to do the conda install c conda forge file requirement.txt. Is that the one? Okay.
Yeah.
Okay, so it seems to be all installed. And now we would, after all the package has been installed, you would need to also install Jupyter. And the first way you can do it is do conda install c anaconda Jupyter. And there's also a different way you can do this if you don't want to do it on the command line, is to go to find, type in anaconda, so where your anaconda navigator is, which is, for me, is here. Then you want to go into your applications and then just click install, like like Jupyter launch or install. It's all, for me, it's already installed. And you can also see some other things like Spider and Jupyter Lab that you can also install. So we're gonna be again waiting for. Yep.
We have a question. How can you test in such a way that you're not missing any edge cases that can happen in production mode?
For a machine learning model.
Yeah.
Yes. So yeah, this is a good question, because in a production environment, which is very different from school, like in a operation or in a company, we have very strict, for example, integration tests, unit tests, and also lots of edge cases that we have to, for the model to run and validate in order to be put into production. So it's a very strict criteria to put into production. But if you're just building out a model, then those would be less severe in that case.
And yeah, we are recording and we'll be sharing it later.
So yeah, it takes very long. All right, I think it's good. So to check if your your Jupyter notebook has been installed, just do Jupyter notebook and it will launch if it's been installed properly. So it should be okay, and just wait a little bit and a window, it will just magically pop up on your browser. All right, so if you are in your correct location, you should be seeing something very similar to mine with a template.ipmb requirements and also our data set. You can go into the template. So if you go into one of the template notebook, it will bring you to this page where I have put out some outlines on the things, on the steps that we will be doing. Or if you don't want to use the template, you can also just create a brand new notebook, which you can do by new and then Python 3. Yep, so all right, so I'll use the template and we will get started. So we'll first load in all the libraries, or just so you can just click on this cell and then just run. And if your dependencies has been installed correctly, it should be, you should not get any error, but I'll see if our dependencies has been installed. So the little star sign here means that our cell is running, and this one will also take a little bit of time. So it looks okay. So if there's no red anything error, that means your cell has been executed and that your notebook is ready to go. So for me, this looks like it's good. Then now I'll be really starting our workflow then. So the first step, like I said, is to really understand your data, really analyze your data and explore your data for any ML thing you're going to be doing. So in our project, we will be doing these specific data analysis exploratory task, but the possibility of this is really endless. You can do so much more to really understand your data. So maybe after the workshop has been concluded, you can think of some other things you can try to explore in your tweet, try to understand in the data. So, but for us, we'll be focusing on doing positive versus negative label tweets, finding out the distribution, checking out the length, and then also analyze the hashtag, and then building out a word cloud visualization. So visualization is also very important in ML. Also make this slightly bigger. And yeah, okay. So let's get started. So the first thing I'm going to be doing is to load in my data set. So we have two data set, a training data set. So training data set is to train your ML model. And then a test data set is to validate your model against. So how your model performs after it has been trained on the training data. So if you're new to Python, you can just follow along, but the syntax I'll be using, you'll be seeing a lot is pandas. So pandas used with how you wrangle data frames in Excels and CSV files. It's very, very important. So train.pd, and pd is the pandas shortcut in which I did pandas as pd. So pd.read CSV, and it just reads the CSV file. So we have to see what's the CSV file name that we have. So we have train. So I'm just going to copy my training set, and then so okay, so we're going to do train, and then we're also going to load in test. We're going to be loading them in before we do anything. And then the same thing. Oh, not this. Must have closed it. So test. And then we will be doing a command called train.shape. So train.shape allows you to see the number of rows and the number of columns of your data set. So for the train data set, we have more than 30K rows and then 3 columns. So this one's the rows, this one's the column. And then one thing we can do is we can just say train row and then equals train.shape 0. So train.shape 0 gets you the row, and train.shape 1 gets you the column. So for now, we just want the train row, train.shape. And let's print that out to see what that looks like. All right, so train.shape 0 gives you the rows. So more than 30K row. And then we can do the same thing. We can do test row goes test.shape. So same thing. We can also print that out. Now we can see how many rows is in our test data set. So in our test data set, we have about 17197 rows. All right, then let's also check out our test shape then. So our test data set has 2 columns. So now we know that, okay, so the test data set is a lot lesser than our training data set, and it's also 1 column less. So what really is in our training data set? So to add a cell, you can just do insert cell below, and we can keep going. So let's actually see what our data set looks like. So we're going to be doing train.head, and just this command will give you the first 5 rows of your CSV file. So you should be able, after launching this command, you should be able to see your tweets. And then we have 3 columns, like we have it here, the ID, the label, and then also our tweet. Okay, so maybe we can also see our test data set also to see what it looks like, just to do some exploration on the data. So okay, cool. So we from that we know it has two columns. So it has ID and it's also got tweet. So label here. So this data set was from a Kaggle competition data set, and in the competition it states to you that 0 means it's negative tweet, and then 1, if it's labeled 1, it's positive tweet. So I only know that because I saw it on their website. So after seeing our training and test data set, okay, so one thing to know before we go further is that in the test data set, there's actually no label. That means, which makes sense because we want to test out whether or not, we want to find out whether or not our tweet is positive or negative. We don't want the answer straight away. We want to find out these labels for ourselves by training an ML model. Okay, so we're going to be doing more data exploring, and this time we're going to be isolating out all the positive and then all the negative tweet. So what I mean by that is to get all, so we do train label equals 0. So like I said, label 0 is the negative tweet. So we're essentially saying that, hey, can I get all the rows that has label of negative tweet? And by just running this command, you should be able to see all the rows that has the label 0. So we can even put a little comment here saying that this is negative tweets in the training data set. Yep, so we keep going. We do same thing to see the positive tweet. So train.label equals 1. This one would be the positive tweet. So these ones are a positive tweet in the training set. And yeah, you can even take some time to read some of these tweets, like in the negative ones, like when a father is dysfunctional and so selfish. So these ones are definitely negative, and these ones are more like positives, or at least neutral in the data set. Okay, so those are some very simple commands we can run. Then let's get going. Let's keep going on what else we can find out about our data set, because in this step it's all about finding out more about our data set. And so now what should we do? So maybe we can actually count the number of, maybe we can even put it in a nice visual way, or counting the numbers of negative and positive tweet. So we can do print train label dot value counts. So that counts the number of our label, which is we have 29, about 29K of negative tweet, and then about 2,242 of positive tweet. And now I'll be using a visual tool called matplotlib to plot out our distribution to make it look nicer than just looking through these numbers. So we can do train label dot, again, value counts. Then we're going to be doing plot. We're going to be making a bar plot, and let's give it a color, maybe purple. And then we can also define a the figure size that will be displaying, which is 6 and 4. So you can, yeah, the bigger you give these numbers, the bigger the plot will go. And then we can run it. All right, so from this command, you will be able to see a plot like this. So that's pretty cool. We get to plot out our our values count. All right, so what else can we do? Maybe we can find out the distributions of the tweets in the entire data set. So again, can add more cells, and we can, for this one, we can do, let's say we want to do checking out the distributions of tweets in the data. So let's do train first. So we'll be doing length. So just call it a variable length train, and then again train, getting the label, tweet dot string str the length, and then maybe this time we will plot a histogram, color purple, and then same, give it the same size, 6 and 4. And then we can do the same for the test. So I'm just gonna do a little lazy hack here and just copy this one and just change the name. So length test, this one will be test tweet. So tweet is the column, and then maybe give it a different color called green. And before that, you have to do PLT. Before that, we can also label its axes. Maybe we can call it label tweet length. And yeah, let's see what that would give us. All right, so that gave us one other new plot with two different distributions on it. The purple one is our training, the length of distributions of our length of the training set of the training tweet, and then the green one is the distributions of each length of the tweet. So it looks that they follow. So the one thing to note here is that even though test set is a lot less than the training set, but they follow the similar distributions. So that's important. So we want so it would correctly reflect, the training set correctly reflect the test set, and they have similar distributions. All right.
Question.
Yep.
Isn't it better to have the same amount of positive and negative tweets so that our data isn't biased, I guess?
Yes, that's very of having, for example, way more positive tweet or way more negative tweet is a problem with come up called class imbalance. So class imbalance would really throw off your accuracy, because now in this case your model is exposed to whatever you gave it the most. So let's say if we have way more negative tweet, because of that in the data set, the model will be exposed to learning and training on recognizing way more negative tweet over positive tweet. So that would screw up the accuracy to some extent, because they are just not exposed to the same amount of stuff. And that's actually a very common problem in ML. So some ways we can combat this is it's either by oversampling the minority class, or undersampling the majority class, if that makes sense.
Yeah.
And some things we can do is maybe use a package called smote, which is the synthetic data to oversample the whole data set, or to undersample. So oversample the minority and undersample the majority class. To synthetic data to do that. But that's a very good observation. Cool. So what else can we do besides I guess any more questions?
I have a question,
Yeah.
Just to jump up of what you were saying, because
Yeah.
you're saying to be over prudent with the smaller class and to be less with the bigger class. But isn't it better to just have two equal ones? Like, I don't understand why we would keep two uneven ones, but then change how we use them, you know?
Yeah, very good. So actually, this is like complete coincidence, but I actually on Project Alicia wrote exactly this problem. And let me just show you very quickly. So in this case, what I mean by oversampling so we can have, we'll take a derail. So let's say we have an imbalanced data set in where the class 0 is way more than class 1. So so you even see it here, the 0, the green dot is way more than the purple dot. This is a imbalanced data set. And one thing we can do is when I say oversample the minority class is that we oversample it to the point of making it completely balanced, like this. So in this case, when we oversample the minority class, it's just a name it's given for this operation, oversampling. But in this case, it would arrive into the point where the data set is completely balanced, and then then we're good to go. That's what it means. So undersampling the majority class and oversample the minority class. It doesn't mean to we do it in the way until it's completely balanced. And the package I use in here is called smote. So yeah, you guys can also check out this package. It gives you the synthetic minority oversampling technique to essentially balance the data set. So you're right, we want it to, the best outcome would be to have a balanced data set.
But if I can just rephrase my question, my question is basically, why do we have to make a balanced outcome? Why can't we start with two equal classes or two equal? Do you get what I mean?
Yeah, so because these data are collected in the real world and they are rarely balanced to start with. It's always through processing that we try to give it the best quality data to feed into our model. So very
Right. So in the
rarely.
real world, there's no such thing as perfectly even. Okay, I see what you mean. Thank you.
In the real world, nothing is perfect. So yeah, we'll always have some very bad data set. Like really bad quality one, like missing values, outliers, all those things would happen in the real world. All right, so we'll keep going. So one other thing we can do besides from finding out these length of the tweet is to okay, so let's just visualize on what we can see on data. So we'll do one more quick thing on the length of the tweet and then we can keep going. So train, we can make a new column. So this is how you make a new column, is to train and then just put the column name you want. And then we can say train tweet dot string dot length. So this one should append a new column, and maybe I'll even do train dot head to see it. So yeah, so now we created a brand new column. This is how we create a brand new column, is to name it. And we can see that, okay, this one has the length of the string is 102 characters and this one's 122. So yeah, these are really fun ways to get to know your data a little bit more. And now I'll be showing you a very cool visualization tool called word cloud. And it goes, we'll first get all the normal tweet, so all the not negative tweet. And so now I'll be showing you something called list comprehension. And for anyone new to Python, it will be something new for you guys. So we'll do normal words, and then we'll start with our list comprehension. So I want to be making a for loop basically. So I'll do text for text in train. I'll explain what this means in just a second, but for text in train, tweet, train, label. So for the when labels are equal to 0, so when we're at our negative tweet, we want to be joining our all our words. So we do a bracket here, and then we do dot join. And so we want to join, this is just a string manipulation to join our words together. And I'll show you what this line means. So this line, it's just a for loop. So this line is exactly equal to this for text in train. Let me just copy. So for text in train, and then we append to a list. We essentially just, you have to create, if you don't do list comprehension, you would have to do this. List dot append, so we're appending our text in a list, and then we, after the for loop, we call the normal words equals to join list. So I hope this is not making it more confusing, but this statement is exactly the same as this, but I have just used something very Pythonic that's unique to Python called a list comprehension, and it looks very tidy because it's only one line. But this one is the same. So I hope that makes sense. So I'll just comment it out so you guys can see it. And we'll keep going. We'll build something called word cloud. So word cloud equal word cloud. So word cloud is a visualization. You guys will know in just a second. It looks very nice, and we get to have some very nice visualization in our notebook. So just setting some numbers, the height, the width. These can be custom to anything you like. Random state, just 0. And then the max font size is 110. And then we can just say generate normal word. So how I know these syntax is it comes from this package called word cloud, where we installed here. So you can check out the Python, this package guide or doc to get to know this package a little bit more, but I'm just following their syntax. And then now we'll be plotting it out. So I'll just set our size again. You can set it to any size you want. I'm gonna set it to 10 and 7. And then we'll need to actually display the data as the image. So plot im show, and then word cloud. So word cloud. And then I don't want the axes because it doesn't look very nice to have the numbers. And then I will have the title. It's called, maybe I'll call it like neutral, non-negative words. And we'll show it. So I hope it runs, or that means I haven't made any typo. So give it a second. This one would also take a little bit of time for it to construct. So if you have typed everything in right, you would get some very nice looking graph here. So that's kind of cool. And yeah, you can go ahead to do the same thing with the negative tweet. So for the negative tweet, you can just, an exercise on your own. The label would just change to 1, and you can plot out your negative tweet to see how the visualization looks like. But this is a very nice visual, and on school project, put it on the cover page and it will give you like full marks. Okay, so now we have probably played enough with the tweets and the visual. Maybe we can look into the hashtag, because hashtag is a very prevalent feature in Twitter. And I can also use this opportunity to tell you guys about the regular expression. So if that's something new, that's also something you guys can, something new that I can introduce you guys to. So
could I ask a question? Sorry,
Yep.
it's just I was looking at the picture and I saw that there's like instead of birthday it says birthday. I think it brought me to. I'm guessing it meant birthday, right?
Yeah. Where is it? Is it on
In
the
the
picture?
picture, yeah, it's right above, not live, the one above.
Oh yeah,
There's
yeah,
not.
yeah.
So my question was, what
Yeah.
happens if there's a typo? Like I'm here, I'm
Mm.
guessing it classifies it as something positive, but there's a typo. So what happens if I write actually like birthday? You know, does it work?
Yeah, so I guess this one lies, the power is in the word cloud and how they also, maybe if it's close enough to the real thing, like close enough to birthday, they would say this is a like a non-negative word, for example, or I mean, so let me say it again. So not word cloud. So word cloud is this place. It lies, the power lies within how this tweet was already classified. So this one is given to us that in the training data set, even the word BH they has been classified as in the normal words. So we're just using it basically. So it comes from how the data set is given to us in this case. So because we haven't trained the model to do any, we haven't even trained any model. It's purely from the training data set. Does that make sense? So maybe the people like the Kaggle competition or whoever built out this data set, they say that if it's BH day was not, it's not negative. Does that make sense? Or
It does. Thank you so much.
okay, yeah. Cool. So yeah, so try out the other words, and then now we'll be doing a hashtag analysis, and I'll introduce you to something called the regular expression. It's basically so the package has been installed in port RE. We'll be using this. So regular expression is basically it's a special sequence of characters that help you find patterns or find other strings that has a specialized syntax in a pattern. So what I mean by that is we can just code it out. So we'll just make a function called hashtag extract. Okay, and then we'll give it a list. So in Python, you can just put hashtags and then a bracket. It's very simple. You don't have to do any like list, hashtag, anything. And then we're going to be making our function in where we can iterate our the variables we put in for I and X. We want to find all the strings that contains the hashtag. Like we know that the pound sign is the hashtag, and then you also have to put into this \w plus and then I. So find all. So for every single character that we iterate through, we want to find all the words that contains the pound sign, which is the hashtag, and then we want to just append hashtags, append that to our empty list that we initially initiated, and then yeah, just return our hashtags. So regular expression is something very handy we can use. And then yeah, let's see this working in real time. So we will do let's say hashtag regular hashtag extract. So we're calling our function here, and then we'll be putting in the variable, which is we'll put in the non-negative tweet for now, so positive or neutral. So tweet, and then train label. So we're getting the our tweet and then our label to be equal to 0. So we always know that 0 is the non-negative tweet. And then let's see what we get from this. So we can just print this out regular. And so maybe I'll just look at, don't print everything out because it might overload. So maybe we can just look at the first 5 thing from the list. So this is how you get the first five element is to do this. And yeah, see what we would get from that. Oh, I didn't run this. Okay, so these are hashtags. We have these hashtags we got. So we just extracted five of them, and then we can now what we can do is we can just, because this one right now it's like nested, like we have nested into a list. So maybe I want to untangle that. So I just want to unnest our list, and I'll again use a new skill we just gained called the our lovely list comprehension. So item for sub list in HT regular. So for sub list in our HT regular, and then for item in sublist. So this is a 2 for loop. So a for loop within a for loop. How you read it is this is the outer for loop and this is the inner for loop. Okay, and then we can print HT regular. And also we can look at the first 5 item. So cool. So now we have nested our list basically into a single list. So that's a much more nicer, that's nicer to deal with than a like, list within a list. So I'll do the same thing with our negative thing. So I'll just copy negative and then change the label. Then copy this, change the variable name. And then you also have to change this label, this too. Cool. And then I just print it out just to see if it looks right. All right, so these are the 2 results we get: untangle and unnested tweets. All right, okay, so let's keep going then. What we can do with this is to let's make a visualization now to visualize these things we can do. So I'll now introduce you to a new visualization tool or a new package called NLTK. So Natural Language Toolkit. And then, yeah, we'll show you how this goes. So tool equals NLTK dot freq dist. So this is a built-in function in the NLTK. So we get the frequency of the text regular. So I'm feeding in the HT regular into our NLTK to get to see the frequency basically. We'll see. So and then we can call it df, so data frame, pd dot data frame. So pd dot data frame gives you a brand new pandas data frame, and then we will put this in like a dictionary kind of thing. We can call this hashtag, and then this can be list tool dot keys. So we're getting the keys from this function we initiated, and then we can also, in this case, also look for the count. So I'll show you what this would look like after we have finished typing. Count. This also tool dot value.
HT regulars are the negative tweets, right?
Say it again.
HT regular,
Yep.
they are the negative tweets.
Non-negative.
Then it should be 1, no? The label.
Oh, is it 1? Did I say 1 was negative or?
1 was for the positive, I guess.
Oh, 1 is positive. Okay, yeah. Okay, good call. Yes. Thank you. Yep, that looks right. Because this is yeah, this is negative. Thank you. Good call. And then we will just we'll print this out. We'll print our dictionary out to see. Okay, so that did that. Yep. So it's a free disk in the sorry, print df. I want to see my data frame, not this function. Okay, so in here we see the hashtag the dictionary we built. So hashtag includes the words and then the counts of the frequency counts basically in the count column. Okay, so now we'll make a visualization again. Maybe we can select the top 20 most frequent hashtags. And then let's do df equals df dot d. So this one is called the ain largest. This is another function specific to pd.dataframe. And then select the columns. The columns is the count. So count. And then n20. So just passing in here will give you the 20 most frequent hashtag. Yeah, hashtag. And then we'll plot this. See it. Anything you like, 16.5 for me. And then we'll use now from matplotlib. I'll be using Seaborn. It's another visualization package. So sns dot bar plot data equals to our df. So our df here. And then the x, we pass in the hashtag column. And then the y, we pass in our count column. And then I'll set the label. Just call it count. It can go anything relative to count. And then I'll show. Cool. So let's run that. So this gives you a very, very nice looking, a very, very nice looking distributions of the 20 most frequent hashtag. And it looks like this one got the most count, and then this one got the. It's how the data set behaves. I did not control this, so yeah, this gives you the counts on the frequency of the hashtag, basically. Okay, so yeah, there's so much more you can do with just exploring the data. You can, for example, get the negative tweet and to see the frequency. You can find out which maybe like the top 50 most frequent hashtag. Anything that you can think of, you can try to do to explore the data. Okay, so I think we have enough for now with the data, and we'll be moving into the cleaning of the data. And I realize it's already 3:07. Okay, is the time okay, Lila, or?
Yeah,
How are you guys?
I know some people might have lectures, so some might start leaving. But
Okay.
Since we're recording, we'll post it to them afterwards.
Sounds good. So I'll keep going. Okay, now
Sorry, where will you posting the recording?
I'll send an email to everyone, but I'll post it on our YouTube channel. You'll get it, don't worry.
Okay, sounds good. Thank you.
No problem.
Okay, cool. Yep, so we will now be moving on to data cleaning. Very, very important because the data is messy. Like even we see it from here, like look at all these like not interpretable signs that we really need to clean out. If we put these in along for a model to learn, it would screw up the accuracy and it would not be very concise. So honestly, a lot of work in machine learning has to do with exploring the data, cleaning the data. I would even say 70% of the work is being done just on the data part. And then the model, it's slightly less frustrated, to put it that way. But you would have to get used to dealing a lot with the data. Okay, so let's get going. So I have already in the template put in the necessary, the needed package you need, where the NLTK and then also stop words and Porter stemmer. And now we'll do cleaning now. So what we can do is to clean the data set. So we can maybe start with, yeah, we can just start with just some, well, eventually put this in a for loop, but I just want to like a simple process. So we can just see one tweet. That will be easy. So let's just run this. Okay, so we'll just be working with this one tweet for now. So the first thing we do is to do regular expression again. So I'll type, this one is the, I'll explain what it means in just a second. A Z train tweet 0. Okay, so what this means, like all of these, it's an XOR expression. So it means that it's not A to Z and it's not A to Z capital. So anything that's not letter or alphabet, we just want to substitute that with an empty string. So that's a very clever way of doing it. And then the next thing we want to do is to get all, like sometimes, people type, they do capital letters. So we want to just keep everything lower. And so that even that you just do dot lower will give you it will return you all the like put it into lowercase essentially. And lastly, I want to split the strings up. So not into a sentence, but into individual words. We'll see why we do that in a second, but just do dot split. And then let's see. So what else do I want to do? So that should be fine. And then we will maybe, so let's just print this out just to see. Okay, so from these operations, we have removed all these very ugly, like a pound at sign. So nothing there anymore beside A to Z. And then we have low capital, like put all the capital. It doesn't show on this tweet, but anything that has a capital will be lowered. And then we have also split these strings up. And then now I'll be talking to you about a concept called stop words. So stop words is basically, let me just put it. So stop words equals set stop words dot words English. So this is where the language comes in. So let me just return, I'll just want to return that. Okay, stop words. So stop words in this dictionary, because I imported it here, in this package, I mean, it returns a list of stop words. So stop words is anything that's like about, above, after, against. It doesn't contain a whole lot of sentiment, and I guess you can like search up what stop words exactly mean, but a lot of the time we remove these stop words to train our model because they don't contain a lot of meaningful things, like compared to things like I'm sad, I'm happy, it's sunny today. So it's sunny today, like it's and like sunny, like the word, like for example, I want to play soccer. I like the word I and then to in that sentence would be classified in the stop words because it doesn't have a lot of sentiment. So if that makes sense. Okay. So we will do now. So now we have done it for one tweet. We have done this for just one single tweet. And I'll put it in a for loop now because we want to do it for the entire training data set. I want to clean my entire training data set and not just one tweet at a time. So now it's just some normal programming. Just we can call it a train corpus, and I'll just put everything I've typed so far in a loop. That's basically what I'm doing. Range 0 train row. We initiated that in the very beginning. And then I'll just do some copying too. So go ahead and put everything in the loop, and of course to replace. And then we also initiate something called Porter stemmer that allows us to get stemming. So stemming is removing any inflection, any ending inflection. So if the word play has some inflections as like playing, played, plays, but they all belong to play. So that's what stemming means. So review stemming. Because again, our list comprehension comes in handy. Word for word in set stop words dot word English. So that's the stop words I just showed you. Okay, the bracket looks good. And then we just want to join them back with space. So because we split it, we want to join them back. We'll join. Oh, review. And lastly, we'll append everything that we have looped through into our training corpus. Dot append. Okay, so I'll just run this. This one will take a long time because remember, our training row has like more than 30K. Like, yeah, like it has a lot of rows. So it depends on how fast your computer is, but this one took a long time for me. So in the meantime, I'll just do the same thing with the test corpus. So exactly the same, but I'll change these.
Question.
Yep.
We're removing things like wasn't, didn't, all of that stuff, but don't they also add meaning? So if someone says I wasn't happy and you remove wasn't, it becomes like a positive sentence even if it was negative.
Yeah, that could also be the case. So about stemming and like even you're right. So even something like play, well, that one is less severe, but with those, if you remove those, it would the meaning would potentially change. So one very cool experiment you can do is to not remove them and see if it changes the accuracy of your model. So you can train multiple models. These are a pre-processing step. Like you can even try like not removing any of these like ugly these special syntax, and you can try not doing stemming and see if it affects the model. But a lot of the time stemming really helps because it seems that it's one of the pre-processing step. But yeah, try it out to see if your model behaves any differently after. But yeah, that's a good observation because sometimes removing these has some cons in a way. And yeah, also one thing you can do is instead of relying on like them giving you stop words, maybe you can just make a list up yourself. Like, okay, I don't want, like when these are like aren't and are, I don't want to remove them, but like if it's like any or and,
Yeah.
then I can remove them. But that's a very good. So yeah, we have to wait and also run this one too. Let me check if I have all things right. Okay, so I did miss. That would be bad. So test corpus. Okay, I'll run this and then we'll go to the next cell as they finish running. Okay, so the next thing we're going to be doing, it's actually, we're almost there to the model building, is feature engineering. And this one way is to do bag of words. There's also TF-IDF you can do, also word embedding you can do, but I'll just be going over bag of words. So bag of words is essentially, okay, so let me go back to our lovely slide just for a second. Okay, so bag of words is we're gonna be, so for model to understand our data, we need to put it in a certain way. And modeling text is very messy, and the model or the machine learning algorithm really prefer like fixed length input and output, and they cannot work with like raw text directly. So we need to convert our text into numbers for the computer, for a model to understand. So we will be building out essentially a vector of numbers. So all in all, bag of words just means text representation in numbers. That's basically it. And it's a feature engineering technique that we'll be using. So it seems still running. It takes a long time, but we can build out our bag of words in the meantime. So it seems very complicated from the photo that I just showed you, but the package called sklearn or scikit-learn has a very nice built-in functionalities we can just use out of the box to do bag of words. And it's like it goes from, so we import it first, sklearn dot feature extraction. So we're just exporting our package dot text import count vectorizer. So count vectorizer converts a collection of text documents to a matrix. So exactly what we want to do here, text into a matrix, into numbers. Okay, so we'll just initiate it, count vectorizer, and let's use maybe just build out 2,500 matrix, like the most frequent one, because the more we get in of, like it would get the more computational heavy this would get. And then CV will fit transform. So all of these are we're just doing count vectorizer transform, and then we can our training corpus. So see it finish running. So train corpus, cool. So it finished running our training corpus, and then we'll do this to array. So to array means we essentially convert developing a matrix, a sparse matrix for every single word. And then so we have our x. Our x is the training, and then we also need our label, our target. It's the so what this mean is ilog is it's a syntax in pandas. So this one gives you all the rows. So that just means that we're getting all the rows, and then comma, and then we're getting the first column. Well, the second column, because it begins with 0. So we're just getting the second column. And let's see we just want to maybe print out the shape. I just want to see the shape of our thing. Okay, transform. Did I spell that wrong? Train. One second. Train corpus. Okay. So yeah, that was a typo. But yeah, so we have, this looks right. So 2,500. So that's the most frequent, the number we pass in to get the features, and then the number of rows stays the same. Looks good. And yep, we're going to be doing exactly the same thing for the test. So our test is the exact same thing, but I want it to be the test corpus, and then it doesn't have a label. And then we can call this X test. Cool. And then we can run it. Looks good. So over 17K, and then exactly the same size. So it looks very, very correct. All right. We finally get to the most exciting part of the course, which is to build out our ML model. So we'll be building out two things: decision tree, and also our random forest. And just a quick overview. So decision tree is it's a supervised ML algorithm that helps us to do classification and also regression problem. So it makes a series of decisions based on a set of features. Probably you guys will be familiar with anyone taking like statistics and math classes. But on the other hand, random forest, it gives it's a ensemble of decision trees. So if a single decision tree does not give you very effective result, that's when random forest comes into the picture. So it's a forest of trees basically, and it it averages the result from each individual tree that's been trained on each feature, and then it gives you the final output. So it's a step up from just a simple tree. Okay, so let's see how we can do that. So we can start by, so before the model, one thing very important is to split the training data into train and validation data set. So that means the validation data set is what we're going to be validating our models on. So from Sklearn model selection import train test split. Okay, so it's another libraries we can use, function we can use called train test split. And then what we can do, I'll just finish typing. So X train, X valid, Y train, valid. We're going to be train test split. So training, testing, splitting are X and Y. So our X and Y variables. And then how I control how much I want to split is here. So I want the test size to be 25. Normally you would the standard would be about 70 training, and then 70% will be training, and then 30 will be validation. Or sometimes people would do 80 training and 20 validation. It's usually in that range that people play around splitting their training data set. So anything within like 20 to 30 is gold. So 42, just a random state. And yeah, so let's just run that so we can have our training and validation data set. All right, so here comes the model. Okay, so we'll be building a decision tree. So from sklearn.tree import decision tree classifier. Okay. And then we initiate our thing, classifier, and then we'll call model.fit. So model.fit, that's where we fit in our training data. So we always just want to fit in our training data. We don't want to be touching our validation data because that's the part that we'll be validating against, not training. Never. So it'll be unfair if we train on our validation data and then validate on that data set again, because that would just be like knowing the result, knowing the answer before you head into like the exam or something. So just print it out to look nice. And then model.score. Oh, before that, I actually missed something. We actually have to call the y predict. So model.predict. So we want to predict our validation data set, our validation data set against our into a new y prediction column so that we can validate our accuracy of this y predicted. So the x is the training data set, and then the y is the label. So the positive and the negative tweet, which is 0 and 1. So we only have 2 labels. And then x train, y train. Yep. Same thing. It would be the validation accuracy, and we want to know both the validation and the training data set, but the most important one is actually the validation accuracy, because the validation accuracy tells us just how accurate our model is. And the training data set, it's also important, but it's the validation, because validation, those are the data we have not seen, we have not trained on. So when you look at a machine learning model and how good it performs, the validation accuracy is the most important, and more important than the training accuracy. So let's just run that. This one would take a while, maybe like a couple of minutes, but we can leave it and then continue to build out our last thing. So the last thing I want to show you is actually the validation metrics, but I'll follow directly. So one thing we can do is look at the validation data set, but that just tells you just how accurate the entire thing performs. It doesn't give you like very insightful answer like did we predict the positive tweets wrong, or did we predict the negative tweet wrongs, like the recalls and precisions and those. So using a confusion matrix is even more important than would be more meaningful and insightful than just knowing the validation accuracy. So just a very, very quick crash course on validation, on confusion matrix. So this, you would, later we'll be building out this graph, but we have true negative, false positive, false negative, and true positive. So I'll tell you what all of these mean. So this means true, we'll start with true positive because that's the most easy one. So true positive is what you predicted to be positive, it's actually true. So what you predicted to be, for example, in email, what you predicted to be actual spam, what your model predict to be spam are actual emails that's spam. So what you predict positive is true. And then we have true negative. So what you predict to be negative is true. So when your classifiers say that, hey, this email is not a spam, then the email is actually not a spam. Okay, if that makes sense. And then we have false positive. So this one is where the errors are. And this one, it has a different name called type 1 error. So what you predict is positive is true. So your model predicts to be a spam is actually real. So you predicted positive, but the reality, it's actually false. And then false negative is when things can even get trickier. So you predict, this one means you predicted negative and it's false. So that means when you classifier predicts that the email is not spam, but in reality, the email is actually spam. So this one is really bad in medical. So think about it. If you, the model gives you saying that a patient is not, doesn't have cancer, but in fact, the patient has cancer, then that would be really bad for the patient because they might like die and not get treatment on time. So yeah. Anyway, let's see how we can apply our confusion matrix into our tweet. So this will be the last one that we'll be doing, and then that will be it for this this workshop. So confusion matrix. So what we can do is from Sklearn. Again, we have our handy little library in Sklearn. Matrix import confusion matrix. And then I just want to initiate y breathe. So we want to build our confusion matrix basing on our validation and our actual our known like validation data set and our predicted thing. And then we'll just plot it out. CM fig x plt and then x dot mat show. I'll give it a color called cm dot blues. And then yeah, I'll just put it in. I'm just graphing it out. So this is into cm dot shape. And then shape 1. So again, the shape, the 0 and 1 just means rows and column. Dot text. So now I want to print out our thing in the matrix. Equals I C. And then just some to make it look nice, center it, horizontal alignment, center. Okay, and then give it a label maybe. Always good practice. Predicted label. And then plt dot y label. This one is the true label. Cool. And then plot dot show. All right, so we cannot run this right now because our model is still running. And then so we need to wait for it to run because we're waiting for this result, waiting for ypre to be fit into this. So we'll run this after this has been run, but now let's go on and build our last model, which is the random forest. So it's actually very, very easy. Just copy this entire thing. And then we'll import, instead of decision tree, we'll import random forest classifier. And then we'll change the name. Okay, and then the rest should stay the same. And then for that one, we will also want to print out the random forest training accuracy, the confusion matrix for our random forest. So let me check if I have everything like correct. So random forest. Okay, it looks good. So I'll go ahead and run these. And then it's just waiting time then. If your computer is like not old like mine, probably you already have the result. Oh, cool. So from our working time, our decision tree has finished running. So we can see, well, of course, we want to look at our validation accuracy. It's about 93%, which is pretty awesome, because 100 is full marks. And then we also get to see our confusion matrix, which this is so this plot is this true negative. So so we can see that it's the like, I don't remember either. So true negative, and true positive, and then false positive and false negative. So yeah, well, I'll see what happened with our random forest, but I want to show you one last thing for this. So how this result comes on, we can actually calculate it ourselves. So remember that accuracy is just whatever the things we get right. So whatever true positives and true negatives we get right. So we can even do something like this. So let's just say all counts equals 7131 plus. So I'm just adding all these numbers up because these ones are, and then 301, 247, 312. Okay. And then I'll take whatever that we have gotten right. So we have gone this right. When it's 0, we predicted 0. So we got that right. When it's 1, we predicted 1. So we got that right. So so we got the 7131 right. And then we also got 312 right, counts right. And then just simple math. You can do it on a calculator too. And then, so this gives you, so what we gotten right is 93% is what this number also outputs. So even without like using the model.score from like out of the box from Sklearn, you can just calculate your own accuracy basically with a confusion matrix. So that's something to really know about. This is a confusion matrix is truly powerful. It tells you what you got right and what you got wrong, to be very precise. Okay, let's see what happened with our random forest. Cannot. Did I spell this wrong?
It looks right.
It looks right. Random forest. Interesting.
Maybe it wasn't downloaded.
I think it might be in the ensemble
Is
rather
it?
than.
Oh, okay. Thank you. Yes, it is indeed in the ensemble. Yeah, because it is an ensemble model of the. Thank you. That should run. Okay, awesome. And then that should also run our confusion matrix too. And yeah, that's basically it. I guess, well, we can wait and see our result and compare to the tree, but I guess any questions or what you guys think?
There was actually a question in the comments. How can we use this for our own tweets? But someone answered like using a Twitter API
Yes.
could help.
Oh, yeah. Okay. I forgot about talking about that part. Yep. So there's something really cool I want to tell you guys. It's called Twiby. And this one is super cool because it's a Twitter API that we can use. And you can, a cool project you guys can do is actually build out like a Twitter bot. So a Twitter bot, so it's Twiby. Check it out. It's very cool Twitter API. You can stream tweets. You can build a Twitter bot. So a Twitter bot is, you can build a bot that sends out tweet like once a day or like every minute, but Twitter would probably ban your bot if they find out. So you can try Twiby to build your own bot. So you can automate your tweets. So if you want to do one tweet a day, you can just build out a little fun bot to allow you to do that.
And you can use it as well to get your tweets and then input it into the model?
Yes, you can. So right now I'm using like a very like set like given training validation data set, but like you can use TweetPU to maybe like scrape a bunch of tweet, stream a bunch of tweet, and then build out a model. So this one is really fun. I had like a lot of fun time building out my bot a few years ago.
I could tell you got really excited about it.
Yeah, TweetPU was really fun. Like I automated like a bot to send out. Like I even saw on Twitter there's a person that's like build out a bot that takes so it takes a picture every single day of a plant and then it tweets it out. So you can see like over a year of time how the plant grows. And it was like a plant bot on Twitter. So that one was really fun.
That's really cool.
Yeah. So that's basically it. Maybe we can wait for our lovely forest to finish up. But that's all I have for you guys. What you guys think? Is it too difficult? Too not difficult? And is it a good intro to machine learning, or is it a bit too much? Maybe we can it can go over the syntax a bit more, or I'm not sure, but I feel like it's a nice way to get to know the entire workflow from like data to like features to model to evaluate. So what you guys think?
If you have any feedback, you can put it in the comments or unmute.
Yeah, because I can't see the comments. So.
I just wanted to ask, in terms of like the words, how the model studies the tweet itself. Does it only rely on the testing and like validation and training actually, or can it like identify like synonyms of different words? Like can it actually identify that big is a synonym of large, even though, for instance, large is not in the testing or training lists? So is it able to do that?
Yeah, so it behaves, so the model trains on whatever training data you feed into the model, and that's all the exposure is going to be given. So if you have like if your training data set is very limited, then the result would not be as good. Like right now we're training on like 30K rows of tweet. Maybe if you just give it like 10 rows, then the result won't be as good. So I think how like to answer the question possibly is that maybe it got exposed to a lot of the instance, like big, large, then it was able to recognize those as in like those words. But if the training data set is really limited, then maybe it doesn't know that it has the same. Does that answer the question or not really?
Partially, but my
Okay.
specific question is like for example, English is really complex and it's
Yeah.
heavily context based. So how is it able, or how is any ML able to identify those like contextual patterns or meanings? You know, like one word can really switch it up. I'm sure this is much more complex than this simple model, but like I often find it like very I'm very curious about like how this works. Like for example, Google Translate. In order to translate something, you need to really understand the context and like the complete meaning of the statement. Is there like a library that does that for you, like English
So
grammar?
yeah, great question. Like simple model like that definitely cannot handle something so extensive and heavy. That's probably when you would turn and go into a neural network. That one is much deeper and can handle a lot more things, like completely taking in the sentence structure, completely taking in like understanding the sentence rather than just looking into individual words and learn from those.
Perfect. Like let's say a professional ML is an 8, 9 out of 10 in terms of difficulty and know-how. How much would you rate this one that we made? Is it a 1 or a 3?
Like this one, this random
Yeah,
forest.
yeah.
Oh, okay, so it would be okay, actually, I have maybe even a picture that can give a more insight on what I'm going to say. So we can say, so there's one called decision tree, random forest, and then XGBoost. So XGBoost I haven't shown because I think it's probably the most advanced. It's the golden like thing in ML for a while, back in 2006 when it came out. XGBoost is the X gradient boost. That one is really more precise than the ML model. So this one gives you a very nice, this picture gives you a very nice thing into the complexity our model. So probably like in the middle, like decision tree might be like 3 or 4, but you can definitely like do a step up. So we use decision tree and random forest. So right here, and then there's something called XGBoost, and then from XGBoost, of course, would have neural network. So like I would say logistic regression might give you the lowest accuracy, but I haven't tested it out. And then if this works, random forest should be better than a decision tree because it's ensemble. Oh, also one more thing is a lot of my my code today is based off a block called let me go back. So a lot of my thing today has been based off a block called analytic vid HYA. So that's where I got like maybe like 80% of my code from. So you guys can also check out his block to get a more to get some more explanation on the things I've done. But let's check in on our, okay, I guess it's still running. I don't like it, maybe my computer is just so slow.
Actually, I have a question. If
Yeah.
you take an actual ML class in university, they probably don't allow you to use most of these libraries, right? They make you build.
Yeah.
Yeah.
This is so correct. So I remember taking a class in McGill called Comp 551. So computer science 551, and it's called Apply Machine Learning. And then, yeah, you cannot use, it's a good course. You guys can also check it out. The professor is very nice and well respected in that domain. So if I have a chance to go to McGill to take that class, I really recommend Apply Machine Learning Comp 551. And yeah, you have to do everything from scratch. I remember I have to like, so in gradient descent, if you know what that is, I have to like handwritten the gradient descent, and you cannot use any package. But maybe you can use like the train test split. I think they allow you to do that. Yeah, and maybe even the confusion matrix. Like as long as it's not model, like model, I don't think you can use. Maybe, I don't know, but you have to do a lot of those yourself. But data, like playing with the data, pandas is very useful. Okay, cool. So it's out. So our random forest 95%. So yeah, it's higher than our 93. So that's cool. And I think that's it, guys.
I just have, I'm sorry, this one last question.
Yeah.
For me, I'm in my second year. I'm doing computer science.
Yep.
And I'm deciding what courses I'm gonna take like for the next year. So I just wanted to ask you, what are some of the non-intuitive classes that you think are really beneficial to us, especially that you had like in-field experience? Of course, there are some like trivial courses to take, such as like machine learning or AI. But what are like some maybe math courses?
Oh,
I
yeah.
heard linear algebra, maybe some say computer vision. So please give us some tips.
Yep. So any class in like apply machine learning, computer, like even computer vision is a very, very nice course, because those like trivial. So trivial class are the class that can actually give you the most direct contact and exposure to what you'll be doing in industry. But classes such as like statistics or like calculus or calc 3, differential algebra, those one, like it's still very important, but you cannot directly apply those classes. Like I'm talking about like algebra, maybe like calculus, for example. You cannot, for example, in an interview say, hey, I know how to derive an equation, rather than I know how to code something up. So those classes are very important too. But I would say if you want to see what really goes on, maybe do some courses in like applied machine learning, computer vision, reinforcement learning. So yeah, for me, that's how it makes sense. I know like statistic is still very important. So maybe don't quote my face on that. Like those are important, like definitely take those, but it's hardly translatable. Like calculus I'm talking about, like linear algebra. I don't know if that's, I'll probably, like your professor will probably not approve we'll probably need to cut this part out in our recording. No, I'm just joking. But like, I'm serious though. So it's it would be just get the coding aspect down, like data structures, algorithms. Those are very, very important. Like as long as you know like one language, learning Python is super easy.
The more practical, the better, I guess.
Yeah, really. Like, but of course statistics would, so if I have to say, statistics would be the most useful course, because it tells you like distributions, whether it's like Gaussian or like multi-model, like long tail, so you get to know which distributions we're talking about. Like even for example, like when we're doing data analysis, this is a Gaussian distribution, like a normal distribution, kind of. And then you will know, okay, so our tweet is our distributions in the tweet make sense, or like there's no like a screwness in the data that I have to maybe like combat.